Long times ago, a group of scientists have struggling in understanding the rocket. They want to fly the rocket into the sky up to 200 meters. Whether flying a small model rocket or launching a giant cargo rocket to Mars, the principle of how rockets work are exactly the same. Understanding and applying these principles means mission success. After research done by Galileo discovered the principle of inertia, that all matter, because of its mass, resists changes in motion. The more mass, the more resistance. However, the relation between the force and the mass, it is described Newton's second law, which states the net force is equal to the mass times the acceleration. Isaac Newton, born the year Galileo died, advanced Galileo's discovery and those of others by proposing three basic laws of motion. Later, they come with the idea that there is action and reaction, which describe Newton's third law. For every action, there is an equal and opposite reaction. However, this is not only enough. Later on, they discover that Newton's first law of motion are also enforced. How that? The net force is equal to zero. In other words, all external forces are cancelled each other out. Naturally, launching rocket into space is more complicated than Newton's laws of motion imply. Designing rockets that can actually lift off Earth and reach orbital velocity or into the space are extremely complicated process. Newton's laws are the beginning, but many other things comes into the play. But finally, they are succeed in launching the rocket into the sky up to 200 meters.
I'm Rishikesh. Today we are going to be talking about the history of rockets, basically the evolution of rockets from the 1st century till 21st century. Now the following clip will be basically on how I illustrated the whole thing in a timeline. Let's go. In the 1st century, the Chinese reportedly had a simple form of gunpowder made from saltpeter, sulfur and charcoal dust. To create explosions during religious festivals, they filled bamboo tubes with a mixture and tossed them into fires. The first use of true rockets was in 1232. At this time, the Chinese and the Mongols were at war with each other. The Chinese repelled them by a barrage of arrows of flying fire. These fire arrows were a simple form of solid propellant rockets. During the 13th and 15th century, in England, a monk named Roger Bacon worked on improved forms of gunpowder and greatly increased the range of rockets, and it is also known when the surface running torpedo was invented. In the 17th century, the scientific foundation of modern rocketry were laid by the great English scientist Sir Isaac Newton, and Newton organized his understandings of physical motion into three scientific laws.
Hi everyone, my name is Jabir Araimi. Knowing Newton's laws of motion explain just about everything you need to know to become a rocket science. However, knowing these laws is not enough. You have to know how to apply them, such as how can you create enough thrust to overcome the weight of the rocket, and also what structure material you should use to create or to build a rocket, and how big your rocket should be, and how can you make the rocket go where you want it to, and how can you bring it back to the earth safely. So in the coming clip, I'm going to explain how the rocket works based on the Newton's laws of motion. Ever wonder how a rocket is launched? First of all, what are the forces act on the rocket in the launch pad? This rocket has a net force of 0. How we notice? The rocket has two forces acting upon it, the gravitational force and the normal force. As you can see from the diagram, there is a gravitational force pushing downward on the rocket at a force of 9.8 meters per second square. There is a force acting opposite to the gravitational force called normal. This force is pushing upward. Since these two forces equal each other, they cancel each other out, resulting in no net force. This means there is a balanced forces, the rocket will remain at rest. This information describes Newton's first law. If an object is at rest or constant velocity, it will remain at rest or constant velocity unless external force is applied. Since there is no external force applied, the rocket will remain at rest. Now let's look to the rocket when it's about to accelerate. A rocket accelerates due to the fuel. The burning of the fuel helps overcome the force of gravity. In this case, the net force is upward, so the acceleration is also upward. This aspect of rocket relieves Newton's second law of motion, which is state an object will accelerate in the direction of the net force. The acceleration is directly proportional to the magnitude of the net force and inversely proportional to the mass. It is represented by the equation F equal to the ma, which is net force equal to the mass times acceleration. For the rocket to accelerate, it needs to lose some mass. The burning of the fuel reduces the rocket mass. This can be represented by a free body diagram, which tells us the thrust force is greater than the gravitational force, resulting in the acceleration of the rocket. This also means the unbalanced forces resulting in a net force to be present. This diagram is a summary of what we have explained so far. Scientists have looked to three factors: force, mass, and acceleration when designing a rocket. They also taken into account different forces interacting with the rocket, such as friction or air resistance. All of this information can be used to know the amount of the fuel needed to suppress friction force. Now, what causes a rocket to lift off? First, let's determine the action and reaction acting on the rocket. In this case, the action force is the rocket pushing downward on the ground with a powerful force from the engine. The reaction force is the ground pushing to the rocket upwards with an equal force. The action and reaction force can be explained by Newton's third law, which is stated for every action there is an equal and opposite reaction. This diagram showing the action and reaction force. Furthermore, when a rocket burns fuel, hot gases burning downward causing the rocket to accelerate to upward. This force is called thrust, which causes expansion of these hot gases. Thrust is a mechanical force generated by engines that help move aircraft through the air and overcome drag. In this case, it's the rocket. It is generated by a propulsion system. Is a system in which a machine produces thrust to push an object forward. The main function of the thrust to overcome the force of the drag and the weight of an object. Thrust is a vector quantity generating in the opposite direction of the accelerated gases. Thrust is the force generated by the change in the momentum of the change in time. Momentum is the quantity of motion of moving body and measured by using the product of the mass and the velocity. It is represented by the equation mass times the velocity. Therefore, the formula of thrust momentum 2 minus momentum 1 over the change of time. This formula is the same formula as finding the slope of line.
Let's start with nose cone, which is aerodynamically designed to provide a smooth flow of air around the rocket body. Next, we have payload compartment section, a section which is used on some models to carry instrumentation, weight, biological specimen, etc. into space. And here we have a parachute, which is basically a thin sheet of plastic or cloth chute which is used to slow down the descent of the rocket, sometimes which is replaced by a steamer or other recovery devices. And next we have the body tube. The whole rocket depends on the body tube. The body tube basically is the structural unit of the rocket which determines the size, design, and the function of all parts of the rocket. And next we have engine truss ring, which glue the inside body tube to hold the engine in a proper position and absorb. And now we have a fins which guide the rocket on a straight flight and give the essential stability for true flight. And here we have launch rod, which is a thin tube which guides the rocket on the launch rod until sufficient speed has been reached for fins to be more effective.
Third law of motion, where across when the fuel burn, it pushes the rocket up. Therefore, the same law of force applies there.
Now Ibrahim will gonna explain to you the advantages and disadvantages of rocket.
I'll be talking about the advantages and disadvantages of rockets. Let's start with the advantages. Rockets are proven technologies. There has been many success and there are different suppliers. Moreover, rockets are extremely fast. They can travel long distances. The longest distance recorded was by Voyager 2 space probe, which traveled beyond Neptune, recording 2.8 billion miles. Another advantage is it creates high-tech jobs. In other words, creating tens of thousands of new jobs, which can boost the economy. Rockets are the only option available to boost people and objects directly from Earth's surface into an orbit. Technically straightforward as compared to jet engines and combustion machines. Rockets can function in vacuum. Last but not least, rockets are also enabled to space travel, military uses, and fireworks for entertainment. Moving on to disadvantages of rockets. The most common disadvantage of rockets is that pollution. Plumes from rocket emissions combine with chlorine gas, which combines with oxygen in our atmosphere, creating chlorine oxide, which destroys our ozone layer, allowing harmful solar rays to pass through our Earth's surface. Another disadvantage is that it's very expensive. The Apollo program from 1961 to 1969 cost us $25.4 billion. A single Saturn launch in 1969 costs NASA $400 million. NASA's Space Shuttle program in total cost $210 billion. Its cost per flight is nearly $1.7 billion per one rocket launch.
First off, we have potassium nitrate here. This one is weighted 15 grams.
So let's add it here to have a finely powder and gently mix it, grind it, make sure it is a fine powder. At this stage, we're gonna add our sugar powder, usually glucose powder, I guess, and add it in the mix. At this stage of the please be careful because this stuff is really high flammable now. So mix it thoroughly. Right now, just spin around. I'm gonna use the tube for the rocket fuel to go in. Put it really nice and tight inside. Okay. Right now this mixture is highly flammable now. So now we are gonna insert our ignition wire, which is just only 2 pieces of wire, which could make a spark inside. And okay, we are done with our rocket motor. We are simply gonna stick up to here. Now our rocket is ready to fly.